Alright, so on this slide, we're actually going to be doing the area model for division. And yes, you did hear me correctly on that. This is a strategy that you can use for division. And the reason why we're using area model is because you're very familiar with it for multiplication. Obviously, since multiplication and division are inverse operations, there is a way that you can undo a multiplication strategy with division. Kind of similar to addition and subtraction. You can add numbers together and then undo the addition by using subtraction. And in that case, we had learned standard algorithm. Now, what we're going to do right now is undo the area model. So, just as a review, let's just take 5 times 22 equals blank. So I have the two factors, I don't know the product. Well, in this scenario with area model, you know that you'd be drawing your rectangle, you're putting your smaller factor on the left, you're doing the expanded form of the larger factor, and in this scenario, you'd be splitting it into two different sections because you have 5 rows going across, 22 columns, but we don't know what 5 times 22 is, so we're going to use the distributive property and multiply 5 times 20 first to figure out what the first partial product is. So in this case, 5 times 20, we know that's 100, and then 5 times 2, we know that's 10. So in other words, the area of this entire rectangle, all we'd have to do is just add the partial products together. 100 plus the 10, well, that's obviously 110. So therefore, the product is 110. Now, that's the area model for multiplication. You should be very familiar with it. Should be an expert on it at this point in time. You know that division is the inverse operation of multiplication. So I'm going to do the equation for division that's in this fact family. So if 5 times 22 equals 110, then that means that 110 divided by 5, therefore, must equal 22. And that's just based on the slide that we looked at before as well. Now, in most scenarios, we don't typically know that the answer is 22. So most scenarios, it's going to be like 110 divided by 5. I have 110 Skittles. I'm trying to split them up into 5 groups. How many Skittles should be in every group? Well, in most scenarios, you don't know 110 divided by 5 equals 22, but I do want you to just keep that in the back of your head so that you can start to make the connection of how we get 22 with the area model. So here's step 1, and it shouldn't be any shock to you. You're actually going to draw a rectangle. I know, it's pretty crazy. And then what's interesting is we already know the area of this. We already know the area because if you remember, the product is actually the same as our dividend. So we already know the area of this entire figure is 110. I'm actually going to write 110 over here on the far left. You'll see why in just a second. I could have written it in the center like we typically do, but you're going to notice that there's a lot of math that has to be done in order to figure out the 22 or the quotient. So we want plenty of space in this white area for us to be able to write. So I always write it off to the far left corner. And I'm taking 110 and I'm trying to split it into 5 different groups. 5, just like above, is going to be on the left. In this case, it's actually our divisor. So we're taking 110, splitting into 5 groups. So in other words, I don't know what 110 divided by 5 is, but there definitely are some basic facts that I could use to help me figure that out. So for example, I want to ask myself, how many groups of 5 can I pull out of 110? And so the easiest thing that I can think of off the top of my head is to think of some double-digit quick trick if I can. So like for example, I could pull out 10 groups of 5 because that would be 50. I could pull out 20 groups of 5 because that would be 100. But I definitely couldn't pull out 30 groups of 5 because I don't have enough Skittles. 30 groups of 5 would be 150. So I know, using my double-digit quick trick, that I definitely could pull out 20 groups of 5. And so I'm actually going to write that up here. This is going to be part of my quotient, believe it or not. And actually, this actually has a special name. It's called a partial quotient. It's part of my final quotient, just like we have our partial products. So basically what I'm saying is I know that I can make 5 rows and 20 columns for a total of 100. And so if I was to do that, I would have 100 x's being created. Like, for example, right in this area right here, I'd have 100 x's. But I know that that's not going to take care of all 110. So if I think about it, I still would have 10 x's left over. And so I know that if I subtract 110 minus 100, I have those 10 x's. And I want those 10 x's to go into my next section. Which, as you can see above, that's exactly how we did it with our multiplication area model as well. And so now I need to take care of these 10 x's. I know that I have 5 rows going across, and so I could have 2 columns of those 5 rows. And that way I would have 10 x's altogether in this section. So in other words, I would have to have 2 columns here. If I do 5 times 2, I get 10. And so that will take care of all of my x's. So 5 times 2 equals 10. I won't have any x's left over at all. And so I know that my final step here is to actually add my partial quotients together. So my partial quotients, again, are up here. It's basically where typically you would put your factor. And so I just have to add these two together, and that equals 22. So my quotient is 22.